Hi everyone. So far we have learned how to set up the Arduino UNO Q board and app lab. We got familiar with the project file and learn how to edit them. In our last video we trained our custom bird and squirrel model using Edge Impulse. Downloaded to the UNO Q and built our bird squirrel detector app inside App Lab. Now, the moment we are waiting for, we are ready to deploy and run the app live on the UNO Q. Let's get started. In my app, I selected the bird squirrel detector app. Before doing any changes in our bird squirrel detector app, I will see if the app working first. Click the Run button. When the app is ready, it will display in the bottom, Bird Squirrel Detector is now running, and it will open a web page. I use photo for birds and squirrel. As you can see, it detected. So far, the app is running okay and detect bird and squirrel. Now we are ready to edit the app to send a command to the ESP32 to control the owl decoy mechanism. It is a good practice to make a copy from the working program and edit the copy. I made a copy and name it copy of bird squirrel detector and edited to send a command to the ESP32 that control the owl mechanism movement. Let us test it before explaining the changes in the UNO Q and the ESP32. In the app, click Run in the top right corner. The app will run and open a web page. When detect a bird or a squirrel, in Python tab will display detect bird or detect squirrel and ESP32 start command sent. The ESP32 blue LED will turn on and the ESP32 will start moving the owl mechanism back and forth every 5 seconds for a minute, then stop. If any bird or squirrel detecting during this minute, it will start the cycle again from the beginning. I edited the main.py using the app lab. The main changes in the main.py is adding the start owl function and a call for this function inside the send detect to UII function if birds or squirrel are detected. For this to work, you have to enter your ESP32 IP address. You will have this when setting up the ESP32. You can download the full main.py file from the GitHub link in the description box. To edit the app.yaml, I will use VS Code. First, open VS Code, open remote window, connect to host, select your board, enter board password, open file, then click OK. Then click the drop-down arrow in the Copy of Bird Squirrel app and open App YAML and edit the description. If you notice the name is still Copy of Bird Squirrel Detector, this will change by App Lab if I change the name of the app. To change the name, click in the three dots in the top right side of the app and select Rename. I will change the name to Bird Squirrel Detector Final. As you can see, the app.yaml has a new name and the changes I made in VS Code. Also, I edited the README file in AppLab, as you see. Now I will explain the OWL mechanism and the control boards. As you can see, the decoy owl is supported in a moving rod. The moving rod connected by sleeve to a linear actuator, moving it back and forth. The ESP32 send a command to the L298 that supply the needed voltage to the actuator and change the voltage polarity depend on the command from the ESP32 to drive the actuator forward and backward. The wiring diagram in the screen shows the connection between the ESP32, the L298, and the actuator. You can download the ESP32 sketch files from the GitHub link in the description box. I will explain how to set up the ESP32 in the next video.